Hello everyone, and today I'm gonna discuss to you the robot software. Introduction. While it is a specific type of software, it is still quite diverse. Each manufacturer has their own robot software, while the vast majority of software is about manipulation of data and seeing the result on screen. Robot software is for the manipulation of objects or tools in the real world. So, what is robot software? So, robot software is the set of coded commands or instructions that tell a mechanical device and electronic system, known together as a robot, what tasks to perform. Robot software is used to perform autonomous tasks. Many software systems and frameworks have been proposed to make programming robots easier. Some robot software aims at developing intelligent mechanical devices. Common tasks include feedback loops, control, pathfinding, data filtering, locating, and sharing data. So, here are the three types of programming methods used for robots. The first one is lead-through method. Lead-through method. This method of programming was immensely popular 10 years ago, but it has since almost disappeared. With lead-through programming, the robot is physically moved through a task by an operator. This has become more difficult as larger robots are becoming commonplace in the manufacturing industry. This not only makes it tougher for the operator, but it increases the chance of hesitation or inaccuracies during the programming phase. This cannot be edited out easily without reprogramming the whole task. Once the lead-through programming has been carried out, it, it can be played back, allowing the robot to complete the task alone. This is an extremely useful method of programming for detailed tasks that would require many lines of code if programmed offline. However, it is not the best option for tasks that are algorithmic in nature, such as simple picking and packing. So, here are the examples of lead-through programming. The next one is teach method. The teach method is the most common, with over 90% of industrial robots programmed rather. The main characteristic of this method is way the robot is taught positional data. A teach pendant with controls to drive the robot in a number of coordinate systems is used to manually drive the robot to its desired location. These locations are then stored and can be revisited within the robot program. While the programming method has been popular for several years, the teach pendant has adapt to suit the evolving user. Early pendants were large gray boxes with magnetic tape storage. Today's modern pendants are more likely to be a touchscreen tablet, something we're all familiar with. Most traditional robots come with a teach pendant, making it the most familiar programming method to technicians. However, it can be disruptive to the manufacturing line, as the robot has to be put into teach mode, and all operations using the robot must be halted while it is programmed. So here are the examples of so here are the examples. So the last one is offline programming method. Offline programming method is a simulation is most often used in robotics research to ensure that advanced control algorithms operate correctly before testing them on a real robot. Programs are developed offline, meaning that the robot only has to be halted while the new program is downloaded and tested. It is currently used by many industrial robot technicians as it causes the least disruption to the production line. Despite its popularity, only a handful of companies are actually using this technology, as it is still in its infancy, but its use is increasing each year. Developers are looking for ways to improve the intuition of the software in order to reduce the time taken to develop the simulation and test it on the robot. No matter what type of programming an operator chooses, they don't need to spend huge sums of money to introduce automation into their manufacturing line. Once a robot is up and running, the manufacturer can rely on reconditioned and obsolete parts to keep their robot operating at optimum efficiency. You might not have completed Robot Odyssey back in the day, but if you understand the basic techniques of teach, lead through, and offline programming, you're all set to level up to the automation era. So here are the examples for the offline programming. So, so here are the four types of control systems used in robotics. The first one is point-to-point control robot. The point-to-point robot is capable of moving from one point to another point. The locations are recorded in the control memory. Point-to-point robots do not control the path to get from one point to the next point. Common applications include component insertion, spot welding, hole drilling, machine loading and unloading, and assembly operations. The next one is continuous path control robot. The continuous path controlled robot is capable of performing movements along the controlled path. With continuous path from one control, the robot can stop at any specified point along the controlled path. All the points along the path must be stored explicitly in the robot's control memory. Application straight line motion is the simplest example for this type of robot. Some continuous path control robots also have the capability to follow a smooth, curved path that has been defined by the programmer. In such cases, the programmer manually moves the robot arm through the desired path, and the controller unit stores a large number of individual point locations along the path in memory. So the typical applications include spray painting, finishing, gluing, arc welding operations. The next one is controlled path robot. In controlled path robots, the controlled equipment can generate paths of different geometry such as straight lines, circles, and interpolated curves with a high degree of accuracy. Good accuracy can be obtained at any point along the specified path. Only the start and finish points and the path definition function must be stored in the robot's control memory. It is important to mention that all controlled path robots have a servo capability to correct their path. So this one is stop-stop. So the stop-stop, it is an open loop system, position and velocity unknown to controller. On or off commands stored as valve states and trouble set by mechanical. So here are the examples of programming languages for industrial robots. Due to the highly proprietary nature of robot software, most manufacturers of robot hardware also provide their own software. While this is not unusual in other automated control systems, the lack of standardization of programming methods for robots does pose certain challenges. For example, there are over 30 different manufacturers of industrial robots, so there are also 30 different robot programming languages required. There are enough similarities between the different robots that it is possible to gain a broad-based understanding of robot programming without having to learn each manufacturer's proprietary language. One method of controlling robots from multiple manufacturers is to use a post-processor and offline programming. With this method, it is possible to handle brand-specific robot programming language from a universal programming language such as Python, the programming language. However, compiling and uploading fixed offline code to a robot controller doesn't allow the robotic system to be state aware, so it cannot adapt its motion and recover as the environment changes. Unified real-time adaptive control for any robot is currently possible with a few different third-party tools. Some examples of published robot programming languages. This one is task in plain English. The other one is variable assembly language. Third one is Stobly-Valtteri. I don't know the term. This one is Epson RC Plus, the example for a vacuum pickup. And the last one is RoboFort, a language based on Fort. Other robot programming languages. Visual Programming Language. The LEGO Mindstorm EV3 programming language is a simple language for its users to interact with. It is a graphical user interface written with LabVIEW. The approach is to start with the program rather than the data. The program is constructed by dragging icons into the program area and adding or inserting into the sequence. For each icon, you then specify the parameters. For example, for the motor drive icon, you specify which motors and by how much they move. When the program is written, it is downloaded in the LEGO NXT Brick microcontroller for tests. Scripting languages. A scripting language is a high-level programming language that is used to control the software application and is interprets in real time or translated on the fly. Instead of being compiled in advance, a scripting language may be general purpose programming language, or it may be limited to specific functions used to augment the running of an application or system program. Some scripting languages, such as Robologics, have data objects residing in registers, and the program flow represents the list of instructions or instruction set that is used to program the robot. Programming languages are generally designed for building data structures and algorithms from scratch, while scripting languages are intended more for connecting or gluing components and instructions together. Consequently, the scripting language instruction set is usually a streamlined list of program commands that are used to simplify the programming process and provide rapid application development. Parallel languages. Another interesting approach is worthy of mention. All robotic applications need parallelism and event-based programming. Parallelism is where the robot does two or more things at the same time. This requires appropriate hardware and software. Most programming languages rely on threads or complex abstraction classes to handle parallelism and the complexity that comes with it, like concurrent access to shared resources. URBI provides a higher level of abstraction by integrating parallelism and events in the core of the language semantics. So, the above code will move the headband and head tilt motors in parallel to make the robot head follow the human face visible on the video taken by its camera whenever a face is seen by the robot. Robot application software. Regardless which language is used, the end result of robot software is to create robotic applications that help or entertain people. Applications include command and control and tasking software. Command and control software includes robot control GUIs for teleoperated robots, point and click command software for autonomous robots, and scheduling software for mobile robots and in factories. Tasking software includes simple drag and drop interfaces for setting up delivery routes, security patrols, and visitor hours. It also includes custom programs written to deploy specific applications. General purpose robot application software is developed on widely distributed robotic platforms. Safety considerations. Programming errors represent a serious safety consideration, particularly in large industrial robots. The power and size of industrial robots mean they are capable of inflicting severe injury if programmed incorrectly or used in an unsafe manner. Due to the mass and high speeds of industrial robots, it is always unsafe for a human to remain in the work area of the robot during automatic operation. The system can begin motion at unexpected unexpected times, and a human will be unable to react quickly through in many situations, even if prepared to do so. Thus, even if the software is free of programming errors, great care must be taken to make an industrial robot safe for human workers or human interaction, such as loading or unloading parts, clearing a part jam, or performing maintenance. The ANSI or RIA R15.06 to 1999, American National Standard for Industrial Robots and Robot Systems, safety requirements book from the Robotic Industries Association is the accepted standard on robot safety. This includes guidelines for both the design for industrial robots and the implementation of or integration and use of industrial robots on the factory floor. Numerous safety concepts such as safety controllers, maximum speed during a teach mode, and use of physical barriers are covered.